Hey everyone, it's Mrs. Weethy back, that science teacher grandma, back to cover other mole calculations. So let's first consider chemical formula for water, H2O. So what does that mean? Well, we've talked about this in the past, and so we know that the chemical formula for water means that you have two atoms of hydrogen and one atom of oxygen. But let's consider this. Let's say that we have 1 mole of water. So, what does that mean? In 1 mole of water, then we have 2 moles of hydrogen and 1 mole of oxygen. And so, what does that mean? Well, those are conversion factors. So, what we can say is that we have 2 moles of hydrogen and 1 mole of water. This acts as one conversion factor between water and hydrogen, and we can flip flop these depending on what it is that we want to try to find out about hydrogen and water. And then our other conversion factor would be 1 mole of oxygen in 1 mole of water. So let's see how we can use that in a mole calculation. So our problem is how many moles of hydrogen are in 13.5 grams of water? Well, list your given and your unknown, just like I have here. Okay, and then because you have grams, and remember I mentioned this before, when you have grams, you have to calculate the molar mass of water. So 2 atoms of hydrogen times its formula mass gives you 2.016. 1 atom of oxygen times its molar mass, 15.9999, add them together, and we get 18.015 grams of water in 1 mole. Units, please. You need to make sure that you use the units. Set up a plan. So you have to start with the number of grams of water because that's what you're given. And so what can you do with grams of water? Well, we can convert that to moles of water using the molar mass. Once you have the moles of water, now you can use that mole relationship to find the number of moles of hydrogen. So you're using what we know in the chemical formula for water to find the moles of hydrogen. Let's set up the problem. Start with your given quantity, 13.5 grams of water, using the molar mass. Now you're going to flip it so that you have 1 mole of water on the top, 18.015 grams of water on the bottom. And then we're going to multiply by that mole ratio, the relationship of hydrogen to water, okay, from the chemical formula. So we have 2 moles of hydrogen in 1 mole of water. Grams is going to divide out. Moles is going to divide out. We're going to do our calculation, round to 3 significant figures, and we have 1.50 moles of hydrogen in 13.5 grams of water. Okay, let's take a look at another example using Avogadro's number. We want to know how many atoms. Remember, atoms is a particle, so that's what we have to use Avogadro's number for to find the number of atoms of carbon are in 16 moles of glucose. Now, we have chemical formula for glucose, C6H12O6. Okay, so given an unknown, and then set up our plan. Now notice we do not have in or given or unknown grams, so we don't need the formula mass of glucose, which is nice because it's a big number. Okay, so we're going to start with the moles of glucose. Okay, and so what can we do with that? Well, we know in glucose we have carbon, so we can convert the moles of glucose to the moles of carbon using that mole relationship in the chemical formula. And then from moles of carbon, we can use Avogadro's number then to calculate the number of atoms of carbon. Let's set up the problem. We have 16 moles of glucose. We're going to multiply by that ratio, 6 moles of carbon. over 1 mole of glucose, and then multiply by Avogadro's number, 6.022 times 10 to the 23rd atoms of carbon over 1 mole. Moles of glucose divides out, moles of carbon divides out, and we're going to round our answer to 4 significant figures, 5.781 times 10 to the 25th atoms of carbon. Okay, that is the end of this video lesson. This is Mrs. Wheatley. So long for now.